Hey everyone. So in this video, we're going to go over how to read data from a flat file and also briefly summarize the data or inspect it to get a sense of what exists inside of it. I'm going to use some data I got from the Boston Area Research Initiative's Tidyverse, and it's going to be looking at places of interest data. Places of interest data are just like places that are of interest, so like a restaurant, a cafe, a lawyer's office, things like that. They're places. And this is going to be a pattern you might see a couple times. And I want to kind of instill some good practices. You'll see right here there is this file foursquare.poi.csv. Now, I want to show you something here that I'm expecting you to read. It's the style guide for the Tidyverse. And what I want to notice here is the file naming conventions. Right here, you'll see that we should have underscores in our files. And I really want to emphasize that periods and file names are restricted solely for indicating the extension of that file. So you'll see that we have .csv for comma separated values, or .docx to indicate that it's a Word document. And then further, you'll see that the name here has a combination of lowercase and capitalized letters. And I want us to instill good practices from the start. So what we're going to do is we're actually going to rename this file. Okay, we're going to rename it to be consistent with our style guide. Our style guide is pretty simple, really. Don't use spaces, don't use periods, use underscores and dashes, and have everything all lowercase. So what I'm going to do here is just make this into foursquare underscore poi.csv. And now this fits in with our style guide. You'll see that we have some inconsistency here with dashes and underscores. That's fine. We're not going to be perfect, but dashes or underscores are going to be acceptable. It's up to you how you'd like to do it. This one right here, ACS 1317 underscore track.csv, that's also from the Bari Tidyverse. And this is more consistent, except it uses all uppercase rather than lowercase. Okay, cool. So now we need to begin to read in our data. We're going to be using a package called readr, from the Tidyverse. And as always, we're going to load the packages that we're going to need to do our work. Packages are collections of functions that help us do our job. Okay, some of you might not have gone through the reading and installed the Tidyverse quite yet. So if that's the case, go over here into your console and type install.packages, Tidyverse. I'm not going to do it quite yet because it can take some time as the Tidyverse is a collection of packages. So let's run this. All right, we see now that I've ran the library Tidyverse, it's executed over here in the console, super, super cool. Okay, so now we want to begin to read the file here. It's called foursquare underscore POI. Okay, how do we do that? Well, again, there are functions that help us do things, one of which is the function read underscore CSV from the package readr. Now, let's quickly look at the documentation here. It says read underscore CSV and read TSV, and TSV stands for tab separated values. So it would look like that, whatever. And these help us understand what function we're going to be using. And these are all similar functions that do very similar things, so they're all documented together. We're interested in this one. So right now, the only thing that we kind of need to pay attention to is the file path. This argument doesn't have a default specified because it doesn't know this is the crux of the function. It reads in a file. You'll see that call names is set to true, call types, etc. We'll go over these later, if at all. And if you have any questions about them, read the documentation, and then if not, email me. Okay, so what we need to do is find out file, either a path to a file, a connection, or literal data. Files ending in .gz, .bz2, .xz, or .zip will be automatically uncompressed. So these files extensions are compressed files. So when you make a zip file, you can unzip that with this function. Additionally, you can actually read CSVs directly from the internet. So if you have like a URL with HTTP, it's going to go straight to the internet and download it there. Okay, so now we kind of get an idea of what this function will do. And we need to point R, or this function, to the data set. Foursquare POI CSV. Let's see what happens. POI.csv. And note, it's inside of quotations, right? Because it's not an object we're referring to. We're creating a character string that points to the file. All right. Well, that didn't work. Why didn't it work? Foursquare POI.csv does not exist in current working directory. Users Josiah, GitHub/BD4C. But you'll actually see it's in the data folder. So since we're working in our project, every thing that when we're referring to files, R is going to start from this folder. So BD4C. It's going to start right here. And since the file Foursquare_POI is in the data folder, we need to tell R to go into that folder first. Because right now it's looking in this folder BD4C for this file Foursquare_POI, but doesn't actually see it here, right? We don't see it. So what we need to do is type data/. And this is the structure of a file path. So we can say that it's within this folder, and if there was another folder, we'd say folder 2/file name. Okay? So now if you run this, it works. It reads in the things that we want. And a couple things happen here. So it's parsed the columns with this specification. So the column GISD becomes DBL, or a double, as you can see here. Double is a type of number that has decimal places after it, whereas an integer is a whole number. Okay, and venue ID, that's parsed as a character string because it's a combination of letters and numbers, so just think of that as a word. Whenever you see character, think of words. Same thing with name and categories ID, categories name, categories plural, etc. Okay, now it prints out this object, and it did that because we didn't actually assign the output of this, which is this tibble, this data frame, right here, a data frame. I'll refer to it as a data frame or a tibble. It's just a table, a two-dimensional structure that we can work with rows and columns. So since we ran this as is, it printed the object because that's what results from the function. But in order to work with this and use it, we need to store it into an object, okay? And how do we do that again? We use the assignment operator. I'm just going to call this object Foursquare. I'm going to use the assignment operator here. So now when I run it, we get the same message, but it's not printed out, okay? That's because it now exists in the Foursquare folder. And if I want to see the object, I can type Foursquare, and it prints it out. But you can see that it doesn't actually print out all the variables. It's kind of hard to see. So there's a function that comes with the package dplyr, which is loaded in the Tidyverse, called glimpse. Glimpse is a really, really cool function that provides a little bit better viewing and preview experience. So it prints, it kind of like shoves it over onto its side. Here we can see that we now know the column names, the type, and the preview of as many values that can fit into our console. So now we get a better understanding of what exists inside of here. Okay, but what do you notice about the columns? You might not notice this at first, or might not think much about it, but the same thing is true with our file paths as our column names. There was a lot of inconsistency here, right? It's using underscores to denote new words, but also it uses lowercase then a following uppercase to denote a new word in the column title here for plural name and short name. This pattern, by the way, is called camel case, where it's like a camel's hump when you have a new capital letter. And it's inconsistent, right? You might forget when to have a capital letter. And for that reason, again, we want to have consistent style. So we want to have all of our column names lowercase and use underscores instead of camel case. And the use of underscores to separate words is actually called snake case. I don't really know why. It doesn't look like a snake. Maybe it's flat. I don't know. But this is something we want to change about our data set. And there's a couple ways we do it, right? So there's an argument inside of readCSV that called call underscore names. And it expects a vector of column names, right? So I could say GIS underscore ID, venue ID, name, categories, ID, oopsies. And the annoying thing is you can't necessarily just specify one column that you'd like to change immediately through this approach, plural underscore name, boom, categories, short name. Ooh, we're getting there. Canonical URL, verified, rating, description, x, lowercase y, and look at this one. This is tricky. Capital B, lowercase l, k, capital ID. That's for block ID. That's a census, so block ID 10, and then census tract ID 10. And then, here, let's take this outside of this. Let's copy this out real quick. And I can print this into the console. See how we have a vector of characters, character strings. This is a collection of related words or characters. It doesn't have to be words, right? It's just not a number. This is a similar approach. This is the same way that we approach sequences of numbers. You can store them in a vector, but they have to be of the same type. If you put numbers with words, it's going to turn into words or characters. Okay, but so now we've provided this vector to the call names argument. If we run this, we have nicer looking names. It's beautiful. But let's be honest, that was really, really cumbersome. And I don't want to do that again. So there's a package called janitor. And as the name might describe, it cleans things, okay? And there's one function in here that I really, really like. This function from janitor called clean names does something really interesting. So what I want to do is actually just copy this, and I'm going to actually call it manual clean names. That's just big messy variable. And then, all right, so if you run this as is, we're back to our original column titles. And then we want to use the function from janitor, clean names. And if you don't have the package janitor installed, run install.packages, janitor inside of these quotation marks. It'll install it for you. Now, there is the function clean names. But since we haven't loaded the package like we did with the Tidyverse, it's not going to show up or be available to us. So we need to preface this with the package name or the namespace colon and then the name of the function. So this is going to tell R, look inside the package janitor for the function name clean names. And we're going to do that. So now we're going to wrap our readCSV function in this clean names function call. So now you'll see that they're clean, just like how we did it over here. And I'll call this four square janitor. Okay, so now let's glimpse this. 4 square janitor. And you'll notice that the message here is with the messy column names. That's because the order of operations here is that readCSV works, and then janitor goes ahead and cleans the name. So it's going to run readCSV as normal and then runs the clean names function. So now let's look at this. We have nice and clean and tidy column names. Beautiful, beautiful, beautiful. Okay, so now that we have our data, excuse me, I want to begin to interrogate it a little bit, get a sense of how our variables look, if there's any missing values, and all that fun stuff. So what we could do is there's another package called skimmer, skimr. And if you don't have that package, run install.packages, skimr, okay, and run that. And it just briefly skims our data set. So if I type, again, I don't want to load the whole library because I don't need every function from it, just one. So we'll run skim Foursquare janitor, and look at this. This is super, super, super cool and super helpful. With one line of code, we are able to understand how many rows there are, how many columns there are, the types of columns there are, whether there are missing values, and we can see that for this description field, there's a ton, so like that's a completion rate of 11%. That might be pretty useless for us. But we can see for everything else that every value is completed. So this completion rate says how many missing values are there. So if there's 100 values and 10 of them are missing, that means there's 90 present values. That's a 90% completion rate. And it'll tell us the number of unique values there are and things like that. And then also it's really, really helpful for our numeric variables is it really shows us the mean, the standard deviation, how many missing values there are, and then also this really awesome sparkline histogram. This is just such an informative way to view our data sets before we even really do anything, right? Like we can see that this rating variable here, it's not actually very completed, so we won't really know much about it. But again, you know what's odd about this is that a lot of these variables are actually shouldn't be treated as numeric, right? These are IDs. So maybe when we look at this, like, why are we looking at distribution of IDs? We should probably change that, right? So we can actually go back into our read CSV function call and be a bit more didactic with the way that this function will read our columns. So let's look at this one argument here. I want you to see. It is call types. And honestly, for the time being, I don't think you really need to understand this. But what you could do right here is I want you to read this. You can use a, quote, compact string representation. You can't see this. I'm using my fingers to make air quotes. Where each character represents one column. C equals character, I equals integer, N equals number, D equals double, so on and so forth. So what we could do is let's preview our data again, right? So Foursquare janitor. All right, we have 15 columns. So what we can do is we can create this little character string. So we know that it's an ID, so we actually want to treat IDs as characters because we don't want to accidentally divide them, multiply them, or anything weird like that. Okay, so venue ID is also going to be treated as a character because that is unique and stuff, and we don't want to do math on it. The name should also be a character string. Categories ID, that's also character. Category name, character. Category place, categories plural name and short name. URL, these are all characters. Verified, I actually haven't seen this. So where do we go? Verified. Looks like a logical thing here where a logical value, by the way, is when can only be two possible values, true or false, right? If you've done any sort of stats, you might have heard of a dummy variable, and these are variables that can only take on a true or a false value, either 1 or 0. Same idea as here with verified. And the rating is not showing up, and I suspect that rating actually might be character, so we're going to treat that as character too. So let's go verified as logical. We can see lowercase l equals logical. I'm going to say rating is also character just in case, because sometimes this parsing goes wrong, and a character is always your safest bet. And in description, that should be character. X and Y, these are going to be treated as doubles because they have decimal places after them. And these last two IDs, they're going to be treated as characters as well. And you'll notice with a lot of naturally occurring data that most of it is really just character values or things like this, because we're not, naturally occurring data aren't necessarily tracking some sort of numeric value. It might be tracking things like this, right? A place, characteristics about it, and a lot of that is done with words and text. So now that we've provided these value types, that message that comes when we print it or when we run this read CSV is gone, because we've told read CSV exactly what type of columns we're after. So it doesn't need to inform us how it parsed it. So okay, I haven't saved any variables named Foursquare, so I'm just gonna call this one Foursquare now. And awesome. One more thing is I want to show that we can view our data sets by clicking this button, which I think I just did previously but didn't explain that. So this gives us that ability to just scroll through our data as we might in Excel, but we can't actually click in here and edit it. That's really good for us. We don't want to be doing things like that because we can't track it. So yeah, if you want to explore this, you can scroll down, so on and so forth. Awesome. Well, that's just reading in data for you.